Welcome to this lecture on Bolzano'S intermediate value theorem by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir. Afternoon, sir.
Good afternoon.
Good afternoon. Okay, so we are going to today do theorem, the Bolzano'S intermediate value theorem. It is similar to the location of roots theorem, and it can be obtained from location of roots theorem. Okay, but it is called generalization of location of roots theorem. Okay, so let us start. Let me share the whiteboard with you all first. So is this whiteboard visible to everyone?
Yes, sir.
We are going to start with Bolzano'S intermediate value theorem. Okay, so also called the generalization of mean value theorem. Generalization of location of roots theorem. So let me give you the statement of this theorem, what it says. Okay, so Bolzano'S intermediate value theorem, it states that if I is any interval, okay, and f is a function, continuous function on I, and AB are 2 points in I, if k belongs to R, okay, so if k belongs to R and it is such that fa is less than k less than fb, then there exists a point C belonging to I between A and B such that fc is equal to k. Okay, is it clear? So if you look, if you want to see it geometrically, so suppose you have this, so let us draw, see what it means geometrically. Okay, so suppose I have this function, okay, so make it as, this is your A, okay, and this one is your B, this point is f of A, and this point is f of B, right? Yes. So what this theorem says that if there is some point k, if there is some point k, if k is some point in this which lies between fa and fb, then there will exist a point C, right? So there exists a point C in the interval AB such that f of C is equal to k. So this is equal to f of C. So if there exists any point in this line between these two, then that point has to be image of some point in the interval AB. Clear?
Yes, sir.
And how it is different from your location of roots theorem? Oh, similar. Why it is similar to location of roots theorem?
सर उसमें k 0 था.
Yes, उसमें k 0 होता है. So fa will be fa या तो नीचे होगा या ऊपर होगा इस x axis के बस. Intermediate value theorem. So basically, if you will change your coordinate system, so location of roots theorem is nothing but intermediate value theorem, and intermediate value theorem is nothing but location of roots theorem, because you can change your coordinate. हम coordinate system तो change कर ही सकते हैं अपने, right? So अगर वो change कर देंगे तो it will become the same thing. इससे both are same results. बस उनको नाम अलग अलग दे दिए, but both are actually the same results. For example, if you have this and if you have this function, okay, so let me draw this function. So let me take a continuous function. Okay, suppose this is your, so same function. अब जो है हमारा coordinate system ये change हो गया है, थोड़ा shift ऊपर ऊपर को हो गया बस basically. So this is your, so this is your FA, this is your FB, and some point k is lying between these two, ठीक है, मतलब 0 k this is your 0 which is equal to k. So यहाँ पे क्या होगा, there exists a c such that f of c is equal to k equal to 0. Fine. So this is your location of roots theorem. And this is your intermediate value theorem. Both are same. You just need to shift your Cartesian system. ठीक है, ऊपर कर दो shift या नीचे कर दो depending on where the values are, and you will see that both are nothing but the same theorems. Okay, so let us now try to prove this theorem. So इसका एक proof तो we can do it using your location of roots theorem. उसके लिए क्या करना होगा हमें, अगर हमें location of roots theorem का use करना है, yes, if we want to use location of roots theorem, तो क्या करना होगा, क्योंकि f तो हमें k वैल्यू चाहिए, एफ सी इक्वल टू के, और लोकेशन ऑफ रूट थ्योरम से तो कुछ 0 पे आना चाहिए, तो क्या डिफाइन करना चाहिए हमें नया फंक्शन,
सर एफ ए माइनस के टू 0 फिर एफ बी माइनस के,
बस एफ एक्स माइनस के ना, तो अपने आप ही सब कुछ माइनस हो जाएगा, ठीक है. सो डिफाइन h फ्रॉम i टू r as hx equal to fx minus k for every x in I. Okay, so since f is continuous on I, so by algebra of continuous functions, h is continuous on I. Okay, now what is h of a? H of a is equal to f of a minus k, which is less than 0, right?
yes sir,
And h of b is equal to f of b minus k, which is greater than 0. Given is f of a is less than k less than f of b. So इसलिए ये this is negative, this is positive. So by location h is continuous on I. So since h is continuous on AB, close interval AB, and f of a is less than 0 less than f of b, so by location of roots theorem क्या होगा हमारे पास, there exists c
सी लाई करेगा,
yes
A और
there
B के
exists, yes, so there exists c belonging to AB such that f of h of c is equal to 0.
0.
So this implies f of c minus k is equal to 0. This implies f of c is equal to k, which is the desired value. ठीक है, so यही प्रूव करना था हमें. Yes.
Yes sir.
So we are able to prove this. Okay, so by location of roots theorem, we are able to prove that there exists a point C belonging to interval AB such that FC is equal to K. Okay, so this is ये जो proof हो गया ये using location of roots theorem हो गया. Let us try to prove this result independently. ठीक है, उससे करते हैं. Basically let us try to prove using the exercise that I gave you. ठीक है, वो वाली technique use करते हैं. So alternative proof. Okay, बाइसेक्शन से तो वी नो कैसे कर सकते हैं, बट लेट अस ट्राई टू प्रूव इट अल्टरनेटिव प्रूफ. सो उसमें क्या करा था हमने, व्हाट वी डिफाइंड, इफ यू रिमेंबर वहां पे. सो व्हाट वी विल डू इज वी विल फर्स्ट, सो विदाउट लॉस ऑफ जनरलिटी एज्यूम दैट a is less than b. ठीक है, so we are assuming that a is less than b because we want to have an interval. So इसलिए हम a less than b assume कर रहे हैं. Now consider the set W equal to X belonging to AB such that Fx is less than K. So we are collecting all those points in the interval AB for which the value of the function Fx is less than K. So then as f of A is less than K, so this implies A belongs to W. So this implies W is non-empty, right? So we have W a non-empty bounded set. Why it is bounded? Because it is a subset of the closed interval AB, right? इसलिए हमने A और B को फिक्स कर लिया, इसलिए हमने ये assumption भी लिया कि A is less than B because we want it, we want W to be bounded set. So W is a non-empty bounded subset of R. ये subset of AB कर दो. So non-empty है bounded है, then what will happen? Yes, non-empty है bounded है, then what will happen? Order completeness property क्या होती है?
सुप्रीमम एग्जिस्ट करेगा,
सुप्रीमम और इन्फीमम एग्जिस्ट करेगा. सो अभी हमें सुप्रीमम की जरूरत है क्योंकि इन्फीमम तो इसका ए है ही. सो वी नीड सुप्रीमम. ओके, सो देन बाय ऑर्डर कंप्लीटनेस प्रॉपर्टी supremum of W exists in R, right? So let W equal to supremum of W. बल्कि ए बी के अंदर ही एग्जिस्ट कर जाएगा क्योंकि बी से बाउंडेड है पूरा सेट. ठीक है. So supremum of W exists in AB. B is an upper bound of this set, na? B is an upper bound of W, so it will exist in this set, and A is a lower bound of this set. So इसलिए supremum जो है it exists in AB. So let W equal to, so this belongs to this set AB. ठीक है. So W अब हमारा claim क्या होगा? Claim f of W is equal to K. So ये हमारा C है, या इसको C बोल दो because we wanted to find C. So let us call it as C. ठीक है. So claim f of C is equal to K. अब सुप्रीमम की प्रॉपर्टी से क्या आएगा हमारे पास?
सीक्वेंस.
यस, कैसे लेंगे सीक्वेंस? फॉर each n belonging to n, C minus 1 by n is there exists xn belonging to W such that क्या होगा? C minus 1 by n is less than xn is less than equal to C, right? क्योंकि C minus 1 by n is not an upper bound for this set, so there exists something bigger than this, right? So there exists some xn which is bigger than this क्योंकि हर एक n के corresponding. So thus we have a sequence. So then xn is a sequence in W such that xn will converge. कहाँ पे converge करेगा?
सी पे.
C पे, क्योंकि ये जब n को infinity पे ले जाओगे तो this will also go to C. ये C है ही, so by squeeze theorem this will be converge to C, right? So xn converges to C. Now xn converges to C and xn is a sequence in W and W is contained in AB and AB is contained in I. So f is continuous at C. Since C belongs to I and f is continuous on I, so by sequential criteria for continuity क्या होगा हमारे पास? Yes. By sequential criteria for continuity, what will happen?
F of x and f of c पे
F of xn will converge to f of c. ठीक है? Now, for each n belonging to n, xn belongs to w, right? Yes. और w में होने से क्या होगा?
ऑलवेज k से छोटा होगा xn का एलिमेंट f of xn.
Yes, it will. F of xn will be. So this implies f of xn will be less than k for all n belonging to n. So this implies limit n tends to infinity, f of xn is less than equal to k for all n belonging to n. So this implies f of c is less than equal to k. So less than equal to k तो आ गया, अब equal to k कैसे प्रूव करोगे? So now our claim is fc is equal to k. So we have shown that fc is less than equal to k. So we have generated a sequence. If you can see, we generated a sequence xn which lies between c minus 1 by n to c. So that converges to c, but f and f of xn is equal to f of c. Now what we will do is we'll take another sequence that converges to c, but from the right of c. यहाँ पे हमने sequence क्या लिया था? From the left of c, right? We took the sequence from the left of c. Now we will take a sequence from the right of c. So again, okay. So now for each n belonging to 1 by n, consider take yn belonging to AB such that c is less than equal to yn less than equal to c plus 1 by n. We can choose one c, yn like this, right? Why we can choose such a yn? Between any two real numbers there are infinitely many real numbers, right? So we can choose one by density theorem. Between any two real numbers there are infinitely many real numbers. ठीक है? So इसलिए एक तो choose कर ही सकते हैं हम उसमें से. So we picked one yn. So हर एक n के corresponding we are picking one yn in the interval c to c plus 1 by n. So then yn converges to c, right? Also, since yn is greater than c, so this implies yn does not belongs to your w. Yes? w में क्यों नहीं belong करेगा? क्योंकि c is the supremum of w और yn is bigger than c, so yn cannot be in w, right?
Yes, sir.
ठीक है? So this implies your f of yn is greater than k for all n belonging to n, right? Because yn does not belongs to w. So this implies f of limit and okay. अब हमें यहाँ पे एक पहले let us just use sequential criteria for continuity here first. Now to since again by sequential criteria for continuity, your f is f of yn will converge to f of c. So basically idea क्या है इसमें कि एक सीक्वेंस हम लेफ्ट से जनरेट कर रहे हैं यूजिंग सुप्रीमम प्रॉपर्टी और दूसरी सीक्वेंस हम ऐसे ही आर्बिट्रली जनरेट कर रहे हैं yn और वो फ्रॉम द राइट ऑफ c और फिर वहां पे सुप्रीमम प्रॉपर्टी का यूज करके हम कह रहे हैं कि yn will not be in w, और जब w में नहीं है तो f of x yn will be greater than k, right? Is it fine?
Yes, sir.
And f of yn is greater than k, so this implies limit n tends to infinity, f of yn is greater than or equal to k, that is f of c is greater than or equal to k, hence f of c is equal to k from star. ठीक है, so this was the main, ये याद रखना है कि हमें एक और सीक्वेंस लेनी है फ्रॉम द राइट ऑफ दिस, फिर अपने आप हो जाएगा. ठीक है, सो एक हमने सीक्वेंस लेफ्ट से जनरेट करी, एक सीक्वेंस राइट से, सो देन वी कम टू दिस प्रूफ. ओके, इज इट फाइन?
Yes, sir.
This is how you can prove this. Okay, now let us come to the next theorem. So हमने Bolzano'S से prove कर लिया, so we can prove one more short theorem. Okay, then we have a corollary to this theorem. This is the corollary, what it says. Yes. I is any closed and bounded interval. F is continuous on I. If k belongs to R is any numbers which lies between infimum of Fi and k and less than supremum of Fi, then there exists a number C between belonging to I such that f of C is equal to k. So कोई बता सकता है क्यों होगा ऐसा? Yes. I is closed and bounded. F is continuous on I. And
सर
k is lying between.
मिनिमम और सुप्रीम में वो भी आई नहीं आ जाएगा, मतलब ए और बी के इक्वल हो जाएगा.
नहीं, a और b के इक्वल नहीं होगा. There will exist some point. ठीक है, it is not necessary that a और b के इक्वल होगा. ठीक है, it may be possible that fa और fb बिल्कुल बीच में ही लाई कर रहे हैं इनके. So since I is closed and bounded and f is continuous on I, so by maximum minimum theorem क्या होगा? Yes, maximum minimum theorem से क्या होता है? Maximum minimum theory क्या कहती है? Every continuous function on a closed and bounded interval attain its bounds. ठीक है, so by maximum minimum theorem there exists x1, yeah, there exists xy belonging to AB such that fx is equal to infimum of fi and fy is equal to supremum of fi. ठीक है, now as fx is less than k less than fy, so by Bolzano'S intermediate value theorem हमारे पास क्या होगा? There exists C belonging to I या C lying between x and y. C lying between x and y such that f of C is equal to k. ठीक है, और अगर C x y के बीच में लाई कर रहा है और x y जो है I A B में है, तो हमारे पास क्या हो जाएगा? C belongs to A B. ठीक है, hence the proof. ठीक है, fine. Is it fine?
Yes, sir.
अभी जो जैसे प्रिंस ने बोला था कि infimum जो है f of a will be equal to infimum of fi. This may not be true in general. ठीक है, similarly f of b equal to supremum of fi. So these two may not be true in general. ठीक है, for example if we take this, so let me show you this. So look at this. Okay, तो इसमें क्या हो रहा है? This is your infimum of fi, right? This is your supremum of fi, and fb is smaller than this, and fa is here, right? So it is not a general in general कि सारा कुछ fa और fb के बीच में लाई करेगा, ठीक है? Sometimes it may lie somewhere else also. Is it fine? So यहाँ पे देखो fa जो है it is strictly greater than m, fb is smaller than m, right? So it is not general कि f of I जो है तुम्हारा ये f of a f of b के बीच में लाई करेगा पूरा ये रेंज, ठीक है? Is it fine?
Yes, sir.
ठीक है, okay. Now we will do another theorem. So simple theorem, वो भी simple है, बिल्कुल इसी पे based है. Continuous image of continuous image of a closed and bounded interval is closed and bounded interval. ठीक है? So this is the statement, if you can see. So what it says, so in other words, it says that continuous image of a closed and bounded interval is a closed and bounded interval. ठीक है? That is f of ab will be closed and bounded interval. ठीक है? f of ab will be closed and bounded interval provided your f is continuous. ठीक है? Provided f is continuous on ab. ठीक है? So this is what this theorem says, that image of a closed and bounded interval is a closed and bounded interval. ठीक है? So let us try to prove this. कैसे prove करोगे? Simple है बहुत. So you have to find एक ये मतलब हमें एक ऐसा, so basically हमें ये शो करना है ना कि this is an interval. Interval का मतलब क्या है कि ये इस फॉर्म का होना चाहिए, कोई x1 x2 तुम्हें मिल जाने चाहिए such that f of ab is this interval. So ये x1 क्या होगा और ये x2 क्या होगा? इसका मतलब क्या है? अगर f of ab सेट क्या होता है? What is the set f of ab? अगर हमें इसे सेट के फॉर्म में लिखना हो, fx such that x belongs to ab, right? So ये वैल्यूज कहाँ पे लाई करेंगे? ये वैल्यू fx कहाँ पे लाई करेगा? ये सबसे छोटी वैल्यू क्या होगी इसमें? Infimum of ab.
Infimum of f of ab.
Right. And this is fx. This is supremum of f of ab. ठीक है? So basically ये यही इंटरवल हो जाएगा, infimum और supremum वाला. So यही प्रूव करेंगे हम. ठीक है? So let m equal to infimum of f of I and capital M equal to supremum of f of I. Claim is f of I is equal to the interval m. So कैसे प्रूव करोगे इसे?
मैक्सिमम मिनिमम थ्योरम अप्लाई कर देंगे.
So by maximum minimum theorem, since I is closed and bounded interval, since I is closed and bounded interval, so by maximum minimum theorem, there exists x1 x2 belonging to I such that f of x1 equal to m and f of x2 equal to कैपिटल M, राइट। तो दो पॉइंट्स मिल जाएंगे जहां पे ये अटेन हो रहे हैं बाय मैक्सिमम मिनिमम थ्योरम, ठीक है। अब हमें ये शो करना है f ऑफ I इज एन इंटरवल, ठीक है। सो f ऑफ I अगर कोई एलिमेंट इसके अंदर है तो वो इसके अंदर शो करना है, और कोई एलिमेंट इसके अंदर है तो वो इसके अंदर शो करना है हमें, ठीक है। तो उसके लिए क्या करोगे, फॉर एनी x belonging to I, m is less than equal to fx less than equal to I m, right? Is it true? And
Yes, sir.
this is infimum, this is supremum. So this implies your f of I is contained in mm, right? ये पूरा इस इंटरवल के अंदर कंटेन्ड है क्योंकि इसमें इसके सारे सेट सारे एलिमेंट इस फॉर्म के हैं, एंड दे आर ऑल इन दिस सेट लाइज बिटवीन m and m, दैट मींस दे ऑल लाई इन दिस इंटरवल। सो एक साइड तो कंटेनमेंट आ गई, अब इधर की कंटेनमेंट शो करनी है। सो इधर की कंटेनमेंट के लिए क्या करोगे हम, यू विल पिक एनी एलिमेंट, सो लेट k बिलोंग्स टू mm be any element, right? Then f of x1 is less than k less than f of x2, right? Is it right? So since f is continuous on I and x1 x2 belongs to I, so by Bolzano's intermediate value theorem हमारे पास क्या होगा, there exists C belonging to I, या C lying between x and y such that f of C is equal to k, right? So this implies k belongs to f of I because f of C belongs to f of I, it is range के अंदर belong करता है ये। So k belongs to f of I, this means क्योंकि k is any arbitrary element of mm, so this implies f of this is contained in f of I, so hence f of I is equal to mm from star, इसको स्टार कॉल कर दो जो हमने यहाँ पे प्रूव करा था। Fine, is the proof clear?
Yes, sir.
So this is the so what we have proved is that continuous image of a closed and bounded interval is a closed and bounded interval. So उसके लिए क्या शो करना होगा कि it is nothing but the interval with endpoint infimum and so with one endpoint infimum and another endpoint supremum, और उसके लिए easily you can show एक साइड तो आ जाएगा आराम से containment कि fi is contained in this by definition of this supremum and infimum, then another for the other part you pick any element, then that element lies between these two elements because f of x1 is nothing but m and f of x2 is nothing but m, या m equal to का लिख भी सकते हो, ठीक है। So by Bolzano'S trust property or intermediate value theorem, Bolzano'S intermediate value theorem, you will have a point C belonging to I such that f of C is equal to k. Now this f of C belongs to this f of I because ये range image हो गया and this is set of all images, so k will belong to f of I, so mm is contained in f of I. Fine.
Yes, sir.
ठीक है, so basically हमने प्रूव कर दिया कि f of I is an interval, right? तो एक रिमार्क है जो you should keep in mind, जो अभी हमने डिस्कस भी करा था, that f of I is equal to mm, f of I need not be equal to a, f of I need not be equal to f of a, f of p, ठीक है, ये ध्यान रखना। फॉर एग्जाम्पल इन दिस केस, तो जैसे अभी कंफ्यूजन हो गई थी ना प्रिंस को कि एफ ऑफ ए से स्टार्ट होगा और एफ ऑफ बी से एंड होगा, सो इट इज नॉट द केस, ठीक है। सो एफ ऑफ आई विल बी द इंटरवल एम एम, ये ध्यान रखना इसको। ये मत प्रूव करने चले जाना कि एफ ऑफ आई इज इक्वल टू एफ ए एफ बी। इज इट फाइन? अच्छा, एक लास्ट थ्योरम जल्दी से कर लेते हैं, दैट इज प्रिजर्वेशन ऑफ इंटरवल्स थ्योरम, ठीक है। सॉरी, so it is similar to what we have done right now, बस यहाँ पे क्या है कि अब क्लोज्ड इंटरवल नहीं दिया हुआ हमें, हमें कोई भी आर्बिट्री इंटरवल दिया हुआ है, but it preserves the interval, मतलब कि continuous image of an interval is again an interval, it can be closed, it can be open, कुछ पता नहीं हमें, ठीक है। in other words, continuous image of an interval is an interval, ठीक है। So this is what we have to prove. So proof, so given is, we are given I any interval, ठीक है, it may be closed, it may be open, and f is continuous on I. To show f of I is an interval, what is the definition of an interval? इंटरवल की डेफिनेशन क्या होती है? इंटरवल की डेफिनेशन क्या होती है, कोई बताएगा? इंटरवल का होता है कि अगर हम कोई भी दो पॉइंट्स उसके अंदर पिक करते हैं, एंड इफ वी पिक एनी अदर पॉइंट व्हिच लाइज बिटवीन द टू पॉइंट्स, देन दैट पॉइंट शुड बिलोंग टू द सेट, ठीक है। डेफिनेशन ऑफ एन इंटरवल लिख देता हूं मैं।
The subset
Definition.
S of R is said to be an interval
Yes.
if any number lying between two numbers in that set also included in the S.
Yes, a subset S of R is an interval if for any pair of points x1 x2 belonging to S, if k lying between x1 and x2 will imply k belongs to S. So हमें ये शो करना होगा, हमें कोई भी पेयर ऑफ पॉइंट्स पिक करना होगा, ठीक है, एंड देन वी विल हैव टू शो दैट ठीक है। सो वी विल हैव टू फर्स्ट पिक अ पेयर ऑफ पॉइंट्स, और फिर उसके बीच में कोई k पिक करना होगा, एंड देन वी विल हैव टू शो दैट दिस k बिलोंग्स टू दिस f of I. सो हमें ये शो करना है, ठीक है। सो let x1 x2 belonging to f of I be any two points, ठीक है। without loss of generality, assume that x1 is less than x2, ठीक है। now take and let k be any point, let k belong to R be such that x1 is less than k less than x2, या इसको इस तरह से भी लिख सकते हो, it's better to write like this, या control Z implies x1 x2 is contained in S, the interval that is k lying between x1 and x2 implies this. So ये मतलब है इसका, ठीक है। So we are picking any k in x1 x2. Now we want to show that this k belongs to fi. How it will belong to fi? So since x1 x2 belongs to fi, so इसका मतलब क्या है, there exists y1 y2 belonging to I such that f of y1 is equal to x1 and f of y2 equal to x2. So since f is continuous on I and f of y1 is less than k less than f of y2, so by intermediate value theorem what will happen? There exists C, yes, in I such that f of C is equal to k, that is k belongs to f of I. So this implies x1 x2 interval is contained in fi since k is any arbitrary point of the interval x1 x2. So this implies fi is an interval. ठीक है? Is it fine? So continuous image of an interval is an interval. इसके एंड पॉइंट्स ना भी हो बट इट मे बी ओपन इंटरवल इट मे बी क्लोज इंटरवल, लेकिन जब भी इंटरवल होगा और उसके कंटिन्यूस इमेज लोगे तो यू विल गेट एन इंटरवल ओनली. ठीक है, सो ये सारे बोल्जानो-वेस्टर्स से प्रूव हो जाते हैं. इज इट फाइन? इज इट फाइन एवरीवन?
Yes, sir.
Yes,
Okay.
sir.
Then let us end this class. Okay. So now we will do some questions based on this tomorrow. And so tomorrow we will do some questions based on this, and then from day after tomorrow we will start the fourth section, which is uniform continuity. Okay. So I am ending this meeting now. Bye everyone. Have a good day.
Thank you, sir.
Thank you for watching this video. Please subscribe to our YouTube channel, Online Learning, to stay updated and share with your friends. Happy learning through online learning. To watch more, click on any of these cards. Thank you once again.